Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrill's Algebra 2 class. Today we're going to continue with the wonderful world of graphing equations in two variables. The two variables we're dealing with is y and x. Okay, a couple things, just little refreshers. Remember that y is always dependent. We're going to get into why that's so important when we talk about functions. And x is independent, okay? What is independent? Independent are things like time. Remember that. Time depends on nothing. Time passes whether you're happy, mad, sad, glad, or afraid. It doesn't matter. It's going to pass. Keeps going. That's independent. When you go to a store, the number of items that you buy, that's independent. Maybe you go to a hamburger place and maybe you're really hungry and you buy 3 hamburgers. Maybe you get to the hamburger place and you realize, you know what? I'm not in the mood for hamburgers, so I'm going to buy 0. So remember that, guys. Y is always dependent. X is independent. Now, when we're talking about graphs of equations with two variables, this x and y, the solutions of an equation or of a function involving two variables can be represented as ordered pairs on a coordinate system or Cartesian plane. What does that mean? That means that the solution to an equation is a point on that equation, okay? It's a point on that line. That's one of the solutions to that line. It's an ordered pair. And the set of all ordered pairs is called the graph of the equation or the function. So when you put all of the ordered pairs that make this equation true, when you put them together, it creates a line. Yes, sir, my brother. Well, thank you very much. The Cartesian plane, remember, is the x and y coordinate. The Cartesian plane is named after the French mathematician Descartes. And watch my first video, and you'll see I have a little story on that, okay? Thank you, my brother. Okay, so table method of sketching a graph. Okay, this is what we've already seen already, but now it's in perfect detail. Number 1, solve the equation for one variable. When possible, it's usually y. In other words, isolate one of the given variables, which is usually y, which is a dependent variable. Okay? Number 2, make a table of values. I don't know why this 2 is here. Sorry about this. Let's get rid of that. Whoa. Okay. Number 2, make a table of values using the moral 5, which is -2, -1, 0, 1, and 2, when the coefficient of the independent variable is a fraction, though. Okay? You want to use 0 and positive and negative multiples of the coefficients of the denominator. And then number 3, the last thing you got to do for this table method is just literally plot the points. Literally. It's that simple. So for example, I want you to graph this right here. Okay, first of all, it's already in y, it's not in y equals form. This is y minus 2x. I have to solve for y. I want to get y all alone. So how do I get y all alone? Exactly. I isolate the variable. How do I isolate that y? No, there is a negative 2x. How do I get rid of that? To very good, my brother. To both sides. Excellent job, guys. Great job. So you're going to go ahead and add 2x to both sides. Thank you. And you're going to now have y equals 2x minus 5. Now I have it in the y equals form. Now I can use my table method. So what's y when x is -2, gentlemen? Okay, it's not 1. It's going to be -9. Because 2 times -2 is -4. -4 minus 5 is -9. Thank you. When x is -1, what's y? -7. When x is 0, -5. Excellent. When x is 1, -3. Darn right. And when x is 2, that's it. So now we're going to graph them. So -2, -2, -9. -1, -7. 0, -5. 1, -3. 2, -1. And this is going to continue forever. So you put arrows on both sides. Do you see what I did? I'm just plugging in the x into the function.
I got kind of confused with those numbers.
No worries. But do you understand? Thank you, my brother. Thank you. Does that make sense to everybody, gentlemen? Yes, sir, my brother. What do you mean? What? I don't. I'm sorry. I don't understand what you mean, sir. With the 1 and the 2x. How did I get negative 9? By plugging in the variable, sir. I'm plugging in this x into my function. Y equals 2 times x, which is negative 2, minus 5. That's negative 9. I'm plugging in the x. So for every different x, I'm going to get a different y. Thank you so much for your honesty. Does that make sense, gentlemen? All right, let's continue then. All right, now, I want you to graph x squared plus y equals negative 2. You may say to yourself, x squared? Please don't be afraid, okay? We're not going to bombard you with this yet. We're going to have a whole chapter, bless you, on graphing all sorts of different functions, and you're going to have to know what's called the parent function of every type of possible function. It's going to have to happen. Why don't we go ahead and today learn 3 parent functions right now, what they always look like, so you know what to expect, okay? So real quick on the side, okay, sorry about that. Right now we're just going to learn 3 functions, okay, 3 parent functions. You have a linear. A linear function is y equals, actually let me go ahead and put mx plus b. If you notice, y and x are in the numerator, y and x have a power of 1. That's going to be a linear. That means that you're going to have a straight line. Doesn't mean it's going to be up or down, but it's just going to be a straight line. Okay? That's linear. Another one we're going to work with that you guys have already worked with many times before is called a quadratic. And a quadratic is in the form of y equals ax squared plus bx plus c. If you notice, x is squared. Whenever x and y are in the numerator and x is squared, what's going to happen here is you're going to get a graph that is called a parabola. And if you remember, a parabola is a U-shaped graph. It could be U-shaped going up or down, but it's a U-shaped graph. So whenever you see an x squared, you know there should be a U coming out somehow, going either up or down. And last but not least, gentlemen, we have, we're going to learn today and talk about absolute value. Absolute value is pretty simple because it's in an absolute value. So you've got a times absolute value of x. Okay, actually, to be fair, it'd be minus h plus k. Whenever you have the x inside of an absolute value, don't worry about the h and k yet. We'll talk about that, I promise. But whenever you have an x inside of an absolute value, you have a V-shaped graph. Please be careful. This is not a U-shape. A lot of times people will find the right values, but they'll make an absolute value a U-shape. I have to mark it completely wrong. Sometimes you have an x squared, it's a quadratic, and you make it a V-shape. I have to make it completely wrong. So if it's just an x with a power of 1, it's linear. It's a straight line always. If you do not get a straight line on a linear, all due respect, you messed up, do it over. You messed up. Yes, sir. Okay. The quadratic, when x is squared, I understand, but I want to go through all of it. Thank you. When it's x is squared, it's a parabola. And a parabola is a U-shaped graph. Absolute value. Okay. The a is just a number being multiplied to the x, and I told you that we're going to go into that in further detail later. The h and the k are just numbers. Okay, the h is a number that's being multiplied, or it's being added to the x inside of the absolute value. K is a number that's just being added to the outside of the absolute value. All right, But whenever you have an x inside of an absolute value, you're going to have a V-shaped graph. Always. Okay, this does not fail. So, with that in mind, I have x squared plus y equals negative 2. What's the first thing I have to do no matter what? Always. Yes, sir. Isolate the y. How would I do that, my brother? Very good. So I'm going to subtract x squared to both sides. So I'm going to get y. Go ahead, tell me. Y. Negative x squared minus 2. I always like to put the variable first. So that way it's easier to solve for me. Now, y equals what when x is negative 2? Please, guys, just plug it in. I do this in my head, but I've literally done 1,000 of these. You do not have to be a hero. You don't have to do it in your head. In fact, I don't want you to do it in your head. I want you to learn the rhythm correctly. So what's the answer here? It's negative 6 because negative 2 squared is 4. But 4 times a negative is a negative 4. Negative 4 minus 2 is negative 6. When x is negative 1, we got negative 3. When x is 0, when x is 1, when x is 2, excellent, son. Does that make sense? And now it's going to be an upside down U, correct? Because I'm now going to plot my points. Negative 2, negative 6, 2, 3, 4, 5, 6. And I've got negative 1, negative 3. I've got 0, negative 2. I've got 1, negative 3, and 2, negative 6. And as you can tell, I did not make a sharp V shape. I made a U shape. If you do not get a U shape when x is squared, all due respect, you messed up, erase it, do it again. This makes sense, gentlemen. Any question on this before we continue, my brothers? It's not too bad, right? Okay. May I continue? All right. Thank you, gentlemen. Okay, how about this bad boy? All right, we got y equals absolute value of x plus 3. It's an absolute value, so what shape is this going to be? A V, and that's it. If you don't get a V with this, all due respect, you messed up, not a big deal, erase it, do it again. So now, when x is negative 2, what's y? Well, I got y equals absolute value of negative 2 plus 3. What's negative 2 plus 3? 1. What's the absolute value of 1? So when x is negative 2, y is 1. When x is negative 1, y is 2. When x is 0, y is. When x is 1, y is. When x is 2, y is. Very good. So now I've got negative 2, 1. Negative 1, 2. I got 0, 3. Oh, this is a good one. 1, 4. And I got 2, 5. Now, what's the problem here, guys? It's not a V yet, right? Guys, is that a V? Okay. Most of you, most people, will just go ahead and graph it and say, oh, well, that's the way it came out. Hopefully not us. Hopefully you'll realize, wait a second. I didn't get a V here. And when I keep going further and further to the right, I end up in this area, right? I don't need that area, right? I need the left side of the graph, correct? So let's pick some better points. So more than just negative 1 and 2, what else do you think I got to pick? How about negative 3? So what's y when x is negative 3? Ah, now we're getting somewhere. Negative 3, 0. What about negative 4 when x is negative 4? What do you got? Negative 4, 1. Ah, do you see now how I have my hook? See how I have the hook now? Now I can go ahead and make my V. I needed my hook, though. Sir, my brother. Because the question was, how did you know you weren't going to get the hook or the vertex on the right side? Because as I kept getting larger and larger this way, I kept going higher and higher this way, right? So I knew that the pattern to the right was just going to keep going up. I know that I needed to go to the left to get the left side. Thank you so much, sir. Yes, sir. Yeah, as long as you have the hook, you're gonna be okay. Now let's look at a couple things just to help you out with the hook. Every absolute value function and every parabola, every quadratic function has an imaginary line called the axis of symmetry. And this axis of symmetry is literally an imaginary line that cuts the graph into perfect halves. You guys remember when you were kids and you were like for Valentine's Day and you cut a little heart out for your mom, and what you did was you just did half a heart on one folded side, then you cut it out, hey, and you had the exact same image on both sides? That's symmetry. So this little pink line here, this dashed line, is an invisible line that cuts it in perfect half. So once you found my hook, do you see how this point here is 2 to the right from my axis of symmetry? So if this is a complete perfect cut in half, I got to go to the left. See how this one's 1, 2, 3 to the right? So now go 1, 2, 3 to the left. See how this one's 1, 2, 3, 4 to the right? So go 1, 2, 3, 4 to the left. And then there's absolutely no question as to your graph. Does that make sense? Promise? Thank you. May I continue? All right. Next. Okay. Finding intercepts. A much better way to graph. Okay. Now we're starting to get to easier subjects here. I think, in my opinion, I think that the table method is long, arduous, and not the most efficient. You got to know it because in a pinch, you can graph anything with the table. In a pinch. There's way better ways, but in a pinch, you could always use a table. So let's find intercepts. When you're looking for an intercept, you have either the x-intercept or the y-intercept. And the x-intercept is the x value on the x-axis when y equals 0, period. It's that simple. The y-intercept is the y value on the y-axis when x equals 0. It's that simple. This guy right here, that's my x-intercept. That particular point right there is 1, 2, 3. This point is 4, 0. It's the x-intercept because it's the x value when y is 0. This bad boy over here is the y-intercept, and that's 1, 2, 3, 4 also. But this is 0, 4, because the y-intercept is the y value when x is 0. So in order to find the x and y-intercept, again, I don't care how nasty and complicated that graph is. You make x 0, find y, that's my y-intercept. You make y 0, find x, that's my x-intercept. Okay? So how does this work? I'm going to graph negative 4y plus 2x equals 12. Now, I've already taught you, yes, sir?
That only works with linear equations, correct?
No. You can find the x and y-intercept for any function, but it's not necessarily going to be all you need to graph it. You're going to, for example, for the quadratic, you can find the y-intercept, but then you got to find your vertex, your axis of symmetry, some mirror images. But if there is a possibility of the graph going through the x or y axis, you're going to have an x and y intercept. It's just not going to be the end-all be-all for graphing, yes. But when you're finding the x and y intercept for linear functions, you can create the graph. That's exactly correct. Thank you, sir. Yes, sir.
First question. The quadratic equation, or the quadratic
This is not a quadratic function.
no, no, but for a quadratic function, does the axis symmetry have to be an axis, like does it be in the middle of the graph somewhere?
No, we haven't even talked about the axis of symmetry of the math of it. Don't start
Okay.
running before you walk, please. No, the axis of symmetry is something different. We're not there yet, please. Okay, thank you, though. I know it's not the x and y axis. Sometimes it is. Let's walk before we run. Okay, so for here, guys, we have y and x has a power of 1. Okay, so it's going to be linear. We know it's going to be a straight line. If you find your x and y intercepts for a straight line, you can graph it. Now, how do you know when you can find your x and y intercepts? How do you know when you have to solve for y? The very simplest answer. This right here is what's called standard form of a linear function. Standard form is ax plus by equals c. If the a and the b are factors of c, you can go ahead and use the x and y intercepts because it's going to make your life a lot easier. So are negative 4 and 2, are those factors of 12? Yeah. So watch how easy this is. Let's find the x-intercept. So the x-intercept, I make y0 and solve for x. So this is going to be negative 4 times 0 plus 2x equals 12. So divide by 2. So 6 comma 0 is my x-intercept. 1, 2, 3, 4, 5, 6. That's my x-intercept. Now let's find my y-intercept. My y-intercept is the y value when x is 0. So negative 4y plus 2 times 0 equals 12. That's gone. Divide by negative 4. My y-intercept is 0 comma negative 3. 1, 2, 3. And guess what? I can graph those 2 points and I'm done. Now I could graph a linear function this way. I can find the x and y intercepts to any function I want, but that's not going to give me the graph of the function. When I have a linear function, though, if I can graph the x and the y intercepts, that's all you need. Connect those 2 points, or those 2 ordered pairs, rather, and you got the line. Sir? If you want to find the rest of the points in this graph, okay, several ways. You can solve for y, make a table, and find as many as you want, or you can follow the slope, but we're not there yet. Okay, but that should be reminding you about what we did freshman year. Okay, thank you very much, kid. So again, when do you use the intercepts? When the a and the c are factors. I'm sorry, a and the b are factors of the c. So when the numbers in front of the x and y are factors of the constant, that's when you use x and y intercept. Does that make sense? Questions, comments, concerns, problems, issues? May I continue? All right, let's do this. All right, so let's graph each. Okay, so here we got y equals 3x plus 1. Trust me, guys, we won't need a table forever, but for right now, we got a table. So let's go negative 2, negative 1, 0, 1, and 2. When x is negative 2, y is? Good, negative 5. When x is negative 1, y is? Correct. When x is 0, y is? 1. When x is 1, y is? And when x is 2, y is? Excellent. So now let's plug it in. So negative 2. We're just plugging in these values for the x. So y equals 3 times negative 2 plus 1. Negative 3 times negative 2 is negative 6, plus 1 is negative 5. Make sense? Promise? Thank you. So now we've got negative 2, negative 5. 1, 2, 3, 4, 5. I got negative 1, negative 2. 0, 1. 1, 4. And 2, 7. And now I literally connect the dots, and that's my line. Does that make sense, guys? Questions, comments, concerns on that, gentlemen? Good, sir? Oh, okay. Number 2, I could solve for y here. I could, but would that be the best way to do this? Why would it not be the best way, and what would be the best way? Sir? Since 5 and 3 are factors of negative 15, what method do you think would be the best way to use? The intercept method. Thank you so much, my brother. Thank you so much. So, guys, the x-intercept. Whoa, I love it when it does that. It's my favorite. So the x-intercept. When y is 0, what's the x value here, gentlemen? Yes, sir. So negative 3 comma 0. So that's 1, 2, negative 3. And then the y-intercept, when x is 0, what's y? 0, comma 5. And literally, you can connect. Does that make sense, gentlemen? Talk to me. If you don't talk to me, guys, I cannot help you. In fact, it is impossible. There's a saying, you can't get blood from a stone. I cannot help you if you do not help yourselves. Please talk to me, sir. Please. I'm using the x and y intercepts here. My x-intercept, make y 0, solve for x, sir. In the problem before, sir, I didn't have the x and y intercepts. I made a table because a and b were not factors of c. Here, do you not see that 5 and negative 3 are factors of negative 15? So then I'm going to find my x and y intercepts. Thank you so much for your honesty, sir. May I continue? Yes, no, maybe, kind of, sort of, guys. Okay, thank you, gentlemen. Okay, let's graph each. Okay, ooh, I got this 0.2 thing. Uh-oh, I don't like 0.2. I like to work with fractions. In fact, that's the best way to work with lines. So how do I turn 0.2 into a fraction, first of all? That's exactly right. This is y equals negative 2/10, but that's going to be negative 1/5 x. Very good, plus 3. Now, can I use my molar 5 here? No, unfortunately not. What can I use, though? Negative 10, negative 5, 0, 10, and 5. Okay, so when x is negative 10, what's y? We got 5. When x is negative 5, what's y? It's going to be 4, yep. When x is 0, excellent. When x is 10, no. 10 times negative 1/5 is negative 2. Negative 2 plus 3 is 1. And when x is 5, yes, sir. So I got negative 10, 5, negative 5, 4, 0, 3, 10, 1, and 5, 2. Connect the dots, and there it is. Does that make sense? Yes, no, maybe, kind of, sort of, guys. All right, next, number 4. What would I do here? Set up a table, yes. What are my, yes, I'm going to go negative 10, negative 5. There you go, great. When x is negative 10, what's y?
8.
Negative 8. When x is negative 5, it's going to be negative 5. When x is 0, when x is 5, 1, good. When x is 10, excellent. So negative 10, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we got negative 5, negative 5. Then we got 0, negative 2, 5, 1, and 10, 4. And you connect the dots, and you got yourself a line. Does this make sense, gentlemen? Okay, how about this? Actually, 5 is the same thing. You can do that on your own. What about 6? It's in standard form, but can I use the x and y intercept method here? No, I can't. So what do I got to do? Thank you, my brother. Solve for y. So let's go ahead and solve for y. How do I solve for y here? Excellent. Very good. Remember, everything is divided by 3, so y equals negative 5 thirds x, leave it as a fraction, minus 4. Does that make sense? Can I use the mole 5 here? Nah. What can I use, though? Negative 6, negative 3, 0, 3, 6. Beautiful. When x is negative 6, what's y? Well, negative 6, you're going to have 10, 10 minus 4, so positive 6. When x is negative 3, it's going to be 1. When x is 0, negative 4. When x is 3, negative 9. When x is 6, negative 14. Very good. So I got negative 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 3, 1. 0, negative 4. 3, negative 9. And I don't have enough space for 6, negative 14. So I can stop right there. Does that make sense, guys? Now listen to me clearly. This is on my recording. I want you to do number 5. Oh boy, that came out nice. I want you to do number 5 on your own tonight. I also want you to do number 7 and number 8 on your own tonight. So please don't tell me that you didn't know this. And I also want you to do the homework, which is valid for 4-2. Thank you. God bless you. Hope you learned a lot and have a great day.